Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 10.1, Problem 6. This is Section 10.1, Problem 6. It says consider the function f of x equals 6x plus 5. And then it asks you 4 questions about that function, f of x equals 6x plus 5. The first question, part A, asks, is 2, 3 a point on the graph of the function? Well, we don't have a picture of the graph, but we can figure it out. Basically what it's saying is if you put in a 2 for this function, do you get out a 3? Well, check it. So if I have f of x equals 6x plus 5, if I put in a 2, what happens is f of 2 is 6x becomes 6 times 2 plus 5. 6 times 2 is 12. 12 plus 5 more is 17. So if I put in a 2, I get out a 17. The point 2, 17 is a point on the graph. But part A asks, is the point 2, 3 a point on the graph? And the answer is no, because if you put in a 2, you do not get out a 3. So the answer to part A is no. 2, 3 is not a point on the graph. Part B says, if x equals 29, what is f of x? So essentially, part B is asking you, if you put in a 29, what do you get as an output? If you use 29 as an input, what do you get as an output? So take the function that's given, which is f of x equals 6x plus 5, and put in a 29 for x and see what you get. So f of x becomes f of 29. 6 times x becomes 6 times 29, and you have plus 5 at the end. 6 times 29 is 6 times 20. 6 times 20 is 120. 6 times 9 is 54. 120 and 54, you're going to have 174. You're going to add 5 more, so 174 plus 5 more is 179. So if you put in a 29, you get out a 179. And again, if you could see the graph, the point over 29 up 179 is a point on the graph. Part C seems the same, but it's different. It says if f of x is 29, what is x? They're basically asking you, if you got out a 29, what did you put in? And again, you can't see the graph. So f of x equals 29. You have a y-coordinate of 29. What's the x that goes with that y-coordinate of 29? If you could see the graph, you'd just look along the graph and you'd find it. But there are a couple of ways to find that. You can just do some trial and error, and you'll get it reasonably quick. Just start plugging stuff in and keep going until you get out a 29. But a better way would be take the function that they give you, which is f of x equals 6x plus 5, and you can say for some value of x you put in, the answer comes out to 29. So you have 29 equals 6x plus 5. What value of x makes that true? Well, just do the algebra required. What I'm going to do is bring the 5 that I have at the end of the right side of the equation over to the left side. It'll become a negative 5. Combine it with the positive 29 that's already on the left side of the equation. Positive 29 and negative 5 is going to give me a positive 24, and I'll have 24 equals 6x. I'll divide out the 6. Divide both sides by 6, and you'll get 4 equals x. So I claim that if you got out a 29, you must have put in a 4. And you can try it. If the function is 6x plus 5, and you're using a value of 4 for x, 6 times x is 24, plus 5 more, sure enough, it's 29. It works. And finally, part D says, what is the domain of this function? Well, again, the domain is what you can use as an input. And there are 2 ways you can be asked the question of what is the domain. They can give you the function as an equation or as a graph. As a graph, you look at what x values the function covers. Now, we don't have the graph. They gave us the equation. So we can basically put in anything we want as long as it does not zero out a denominator or put a negative under a square root, or more technically an even index root, but I typically say a square root in class. This function has no denominator, and it has no type of root of any kind. So what can I put in? I can put in anything I want. I can't get into any trouble. I can put in positives, negatives, fractions, decimals, anything. So the domain is all numbers. If this was in a book and you'd see the answer in the book in the back, they'd say all real numbers And you might say, well, what other type of numbers are there? There's also complex numbers, which this class doesn't really get into. So we can just say all numbers. The domain is all numbers. What can you use as an input? You can use all numbers as an input.